When solar particles crash into Earth's upper atmosphere, they are funneled toward the poles by an invisible force, creating the northern and southern lights. That magnetic field acts as a planetary shield, deflecting harmful radiation. Without it, solar winds would strip away the atmosphere and boil off the oceans, leaving the planet sterile. Because this shield is so central to habitability, astronomers have spent 15 years scanning the galaxy, trying to measure it on other worlds. But because magnetic fields emit no light of their own, they remain invisible to our telescopes. Recently, a team of researchers using the Very Large Telescope in Chile and the Gemini North Observatory in Hawaii focused on a different question, measuring the weather on 7 distant gas giants. By tracking how fast the wind was blowing on these alien worlds, they found the first robust evidence of the magnetic forces hiding underneath. The study focused on hot Jupiters, massive fast giants that orbit exceptionally close to their host stars. Sitting so close, these planets are tidally locked. One side is trapped in a scorching perpetual day, while the other sits in endless night. This temperature divide expands the atmosphere, forcing air to rush rapidly over the terminator line toward the cold hemisphere. On these worlds, the wind speeds range from 7,200 kilometers per hour to over 25,000. For comparison, the fastest winds ever measured on our own Jupiter reach only 1,500 kilometers per hour. However, as the team compared these speeds across different planets, they found a physical relationship that contradicted the established rules of planetary weather. In thermodynamics, thermal energy dictates motion. A hotter planet has more energy available to its atmosphere, which should accelerate its winds to higher speeds. This chart shows the measurements taken from the 7 hot Jupiters. As the planets get hotter, the winds actually get slower. The planets with the most energy were producing the least amount of wind. The explanation lies in the heat itself. These planets are hot enough to ionize their atmospheres, stripping electrons away and turning the wind into a flow of electrically charged particles. As this charged wind attempts to whip around the planet, it crashes into the planet's magnetic field lines. This interaction creates a physical drag. The magnetic field works like a planet-wide brake system, slowing the motion of the charged atmosphere as it tries to pass through. This counterintuitive slowdown is the first empirical evidence of massive magnetic fields operating on worlds outside our solar system. By calculating the deficit in wind speed, astronomers can now mathematically reverse engineer the exact strength of these invisible fields. The data reveals that these exoplanets possess magnetic fields roughly half as powerful as Jupiter's. While smaller than Jupiter's, these fields are still exceptionally robust, measuring roughly 4 times stronger than the field surrounding Saturn. Astronomers plan to apply this same deductive method to smaller, rocky planets using the upcoming Extremely Large Telescope. A moment of wonder. On the planets in this study, the interaction between the field and the wind likely creates spectacular displays. Some of these worlds may have skies filled with vast curtains of colorful light dancing across the half of the planet in endless night. By learning to read the forces hidden inside alien winds, we have found a way to detect the magnetic shields that keep planets alive.